Hello everyone, welcome to the video. Today we're gonna do a simulation of robotic arm with 3 degrees of freedom in 2D space. So here in front of you can see a Matlab code. So first I would like to do the simulation and then I can explain how the code is. So yes, in front of your screen you can see the movement of 3 joints, and now it has stopped. So in the first part of the code, you can see there are arm parameters and desired end effector target. So when we change this, let's see what happens, then we can understand how the code is. And yeah, so let me give the x0 and keep y1, and if you want you can change this to 1 and see that, notice the changes. You can notice the changes, the length has decreased, and also see the way it goes. So here it will look like it's gonna collide, but no, this is a 2D space, and when we do the simulation in 3D space, it will not collide. Yeah, so coming back to the Matlab code. So just now we saw how changing the arm parameters and an end effector target can change the way it will simulate, change the way the arm chooses to move. So coming back to the code, I would like to show you the maths involved behind this. So we use inverse kinematics to calculate the angles, and we will use the forward kinematics to calculate the joint positions. So this section of the code, it only calculates for the first 2 links and first 2 angles. That's why it's mentioned 2 degree of freedom function, and when we have a third link and angle, this equations comes into place. So here you can see that we are creating a function with 2 angles and passing the end effector values and link 1 and link 2 lengths. This is a direct equation taken from inverse kinematics, and this d here is the cos of theta 2. So once we calculate the cos of theta 2 and it's not greater than 1, then we go to this set of equations. This is a direct formula again. Theta 2 is been calculated using the arctan 2 of sine of theta 2 and cos of theta 2. Here the square root of 1 minus cos square theta 2, so that gives sine of theta 2, and this is cos of theta 2. So using the x and y coordinates and arctan 2 function, we can calculate the theta 1 as well. So now if we have a third link and third angle, we can calculate that as well using this set of formula. So here first we solve for the theta 1 and theta 2, and then we can calculate the theta 3. So if anybody is interested to learn or is new to this, I am giving a link of a YouTube video where they will teach you regarding the maths involved and the equations involved in this. So now coming into calculating the joint positions, here we are using the forward kinematics. So first we will be calculating the joint 1, then using the x and y coordinates we will be adding that to the joint 1 to calculate joint 2 and joint 3 and so on. So coming to this section of the code here, so this plots the final arm configuration. So here you can see this is for the x-axis and this is for the y-axis, and if you have a z plane, we need to add joint 1 of 3, joint 2 of 3 and joint 3 of 3 and end effector of 3. So that will give you third dimension. So coming to the animation, so for simulation we need to first define a time frame, and according to that time frame, at that particular time frame we need to calculate the angles and also the joint position at that particular time frame. So that is what you can see here. The T1, T2, T3 are the angles at that particular time frame, and also using that angles we are calculating the joint positions, and we are plotting this using this command. And this pause here, this is the speed of the simulation. So if you give it a 0.1 and let's see the simulation, yes, you can see it's a slow simulation. So if you need a faster simulation, you need to decrease it. And now if you want to make the robotic arm accelerate gently at the start and slow down near the end, you can do one thing. You can add this line of the code here, and yeah, you have to also change the D to S here, and let's check what happens. Yes, now you can see the difference here. So it is accelerating gently at the start, and yeah, it's slow when it comes to it. Yeah, so this is a simple Matlab code for a simple exercise. I mean, this is a very basic exercise when it comes to robotics, and yes, I would like to do something new in the next coming videos. Like we'll try to do this in a 3D space with maybe obstacles. So in this video, we just observed how changes to target positions and length changes can contribute to changes of the arm motion. So how the arm chooses to move provided the target position and provided the length. So it's important to know this when you design the control system for a robotic arm in an industrial robot, where there are also obstacles and a lot of things which we need to take care. So this is a basic learning, and yeah, I would like to come up with fresh videos with new learnings. Thank you.